couple of issues that we've got the stepper motor smoothing rod yet to be fitted here, and looks like I'm going to have to grind a step in here to make this fit. Not real happy with these lightweight GT2 belts, so I'm going to change that. I have got the limit switch set up here, and there's one here, and of course there's one over here. Now that limit switch runs down inside up the tube, comes out over here, but unfortunately for me it wasn't long enough, so just going to have to splice a bit of cable into that. This box here, I'm using the plastic bolts on it, and I've had to grind two of the heads on the lower section to fit in between the pin rails. So I've just used the plastic or the acrylic bolts, so it's all nice and safe. That's just sitting there waiting to be soldered at the moment. So this will sit down here, and I've got to put the other belt on yet. The issue that I've had with this guy here, for some reason my printer didn't make this wide enough, so I'm finding it hard to get the belt in, so I have to put a 3mm screw behind that there and then push that to open that up to get the belt in there. But this is going to be obsolete shortly. I'm going to get rid of this and this mechanism, and of course this mechanism down here, and I'll show you what I'm going to do there shortly. We've got the belt all set up here, and I've put the wing nuts on here for adjustment. This is the belt I had 2 lengths of belt, one for this side, one for that side, and the offcut just didn't quite make it across, so I've joined it there with teeth to teeth in like so, and that holds, and when that comes across, well, you can see that in there, but it virtually doesn't run up against that. So that all works at the moment. I've got the router set in there, as you can see, and you can see how high it is off the deck. That will actually sit on a bit of an angle, otherwise it fouls with the limit switch and here with this part of the router. The limit switches are all fitted up here and the pulleys fitted in. As you can see there, that bracket's probably not the strongest. Going to do something with that. I was even thinking about mounting that drive directly on top of here, but obviously you need a ratio to get the speed out of it, so don't know what I'll do there yet, but anyway, that's how all that will look. If we take a walk around here, you can see where I've got the belt actually in here and all set up and clipped up and ready to go. A little bit of an issue here, I'm going to have to take this wiring down underneath the belt rather than over the top of it. There's no way of holding that, so it's going to have to come down here and go straight in underneath there. But basically that's the mechanism there, all working. Pretty happy with that. I've actually ran this and tested it yesterday and commissioned it, and yeah, had all the limits around the wrong way. You've got to make sure you get your right limits on your board there. Even though it says X, Y and Z and there's 2 for each, you need to make sure you've got the right one. So the idea would be to commission, or when you're commissioning your unit, don't have the belts and the drive on. So I just had mine spinning, and then I'd hit the up button and it would start to wind up, and I would hit the limit switch to make sure that I had it right. Had them around the wrong way, had those around the wrong way, so it's just a matter of taking them off the board, spinning them around. So basically that's the walk around the unit as it is there at the moment. So if we come over here to the bench, it's probably not the best of colours to be contrasting there, but there's one of the NEMA 17 motors, the 8mm Acme threaded lead screw, and that's the standard nut that comes with it. And I bought these, they're what they call an anti-backlash, and they've got a spring on there with a second follower, and basically that spring just applies the tension and takes out the backlash there, so you don't have that wobbling around. So the idea is to mount this bracket with the NEMA 17 motor in it on the coupling with the long threaded rod, and to have a holder or captured bearing down one end and a follower. So what I did is I decided to buy the longer threaded rod. So obviously the machine here, the threaded rod needs to go from up this end all the way down to here and be captured onto the gantry. So it's 650 millimeters. So I bought some 800 millimeter threaded rod, and this is going to be the configuration there. So if we have a look here, this is a bracket I downloaded on Thingiverse. It was just I just punched in lead screw bracket, and I got this and I printed it out. But what I found was, for some reason, pretty sloppy in regards to the fit and the bearing. When I go to put the bearing in there as well, the bearing was too sloppy. So, and also the height of it was sort of wrong when I mounted that with that. Obviously that is somewhat up in the air there. You can sort of see that that's running downhill. If you have a look at that, you'll see it's running downhill. So I got onto Fusion 360 and I just extruded a bush, and that bush was meant to go in there and be a nice press fit, and then of course that and the bearing just fits in there as a nice press fit or slide fit as well for this. So put one of those bearings in there. It's a 608 2RS, and the 2RS just means it's 2 dust seals, those black seals there. ZZ means it's a shield, and if it's only if there's no number after it, obviously it's an open cage. So that's just a seal for life bearing, and that is pressed into that. So what I did after I made that bush and I made that, I printed that out and I thought, it's nice but a little bit too high. I decided to go in a Fusion 360 and make myself a couple of brackets of my own. So I started from scratch, and what I did is I basically followed the same diameters, same step, or the same thicknesses, but basically just made a smaller version. You can see there it's a lot narrower, or it's a lot smaller. So that, and it's a little bit wider as well, made it just that little bit wider to give the bearing that bit of protection in there. You can see it's recessed back in. Now that one there is a really nice press fit. So if we forget about that now, that was our prototype with the bush. We forget about that. What we're going to do is we're going to have that, and that's a nice press fit into there. I'll put this down for a minute, the camera. So the whole idea here is, I think you can see the picture there, have the stepper motor mounted on the base with the lead screw. There'll be one of these at the end, which is just the bearing to hold it in place and stop it from wobbling around, and there'll be 2 of these. One will just screw them straight into the, so you get the idea here. We've got the bearing on that end just to hold it in place, the bracket with the motor in it on that end, and this guy here will just have a bracket facing that way, toes facing right, there'll be another one facing left, and that'll be a little way apart, and that'll be mounted to the side of the gantry. So here's all our electronics. Here's the other bench. Here's some of the bits and pieces left over. Here's a dead stepper. The reason it's dead is I wound that little pot too far and killed it. This is my original first go at these, and as you can see they were that tight that I put the grinder through there to try and clean it up. It wasn't successful, so they're rubbish. I think I've explained about those previous video. They were the wrong ones. So, and there's our power supply here. There's our two more stepper motors there. So there's our plug with our 12 volt on it. Haven't cut any of the other cables off yet. I'm still thinking about putting a row of LEDs on there, and I've got to run the fan as well, probably with a 5 volt. So if you're using one of these, there's plenty of videos on the net about how you modify the ATX box. Now this isn't an ATX, this is just a normal power supply, and yellow is 12 volt, red is 5 volts. So and obviously the switch there. So I'm thinking about taking that power supply and the switch out and mounting that on the board, and another base plate that's going to come out on the bottom of that and extend out. So really what I should have done, I should have just left that at a you know, another 300 millimeters and had room to put the power supply and this guy out the back. But for the time being, we've made it exactly as per the sketches on Thingiverse, and I must say I'm pretty happy with it all up. Probably about 220 hours worth of 3D printing. All up, labour wise, I've probably spent 20 to 30 hours putting all this together, getting everything right, you know, working out how I'm going to get it all assembled and how it's all going to work, and you know, getting limit switches commissioned and the like. So I reckon I've probably got another 5 or 6 hours just getting little things like that, wiring over the top, or sorry, underneath the belt,